Have you ever wondered what's really behind the most catastrophic failures in our modern world? And I'm not talking about small slip-ups. I mean the big ones. The disasters that cost fortunes, futures, and even lives. We're going to dive into that because it turns out the answer is hiding in plain sight, and it's something we all deal with every single day.
We see the fallout when these complex systems fail in the sky.
We see it when they absolutely cripple our economies, in the blink of an eye.
And most tragically, we see it when technology that was designed to save lives ends up taking them.
So what's the common link here? What's the invisible thread that ties a downed airplane, a market crash, and a medical tragedy all together? It's not a faulty piece of hardware. It's not even a single line of bad code. No, the real cause is something way more fundamental.
It all comes down to this: poor requirements. Now, I know that doesn't sound super dramatic, but a failure at this very first stage is the single biggest reason why complex systems break in the most catastrophic ways.
So what exactly is a requirement? Well, think of it as the system's DNA. It's the official blueprint that spells out exactly what a system has to do, and just as important, why it has to do it. Every single decision that comes after, from the design to the code to the testing, it's all built on this foundation.
And this quote just nails it. It doesn't matter if you have the most brilliant engineers on the planet or the most cutting-edge technology. If that initial blueprint is off, the final product is guaranteed to be a failure, period.
Okay, enough theory, let's get into the real world. To really see the devastating impact of this, we're going to look at a couple of cautionary tales that show exactly what happens when requirements go horribly, horribly wrong.
First up, we're heading to Wall Street back in 2012. This number right here, $460 million, that's how much money the trading firm Knight Capital lost. But you know the really insane part? They lost it all in just 45 minutes.
And you'd be shocked at how simple the core mistakes were. The requirement to turn off an old piece of code. It just wasn't clear. So when a technician flipped a switch, it accidentally woke up this dormant, destructive trading algorithm. And crucially, there was no safety requirement. Nothing that said, we need a kill switch or we need a rollback plan. The system had no documented way to stop itself from literally bankrupting the company. So, the big takeaway is this. Your requirements don't just define what a system should do. They absolutely must define what it should never do. This isn't just some nice-to-have feature. It's a fundamental rule of survival, and it has to be in the blueprint from day one.
All right, let's move on to our next case. And this one's a lot heavier. It's truly tragic. The Therac 25 was a medical radiation machine. It was designed to treat cancer. Instead, because of a whole series of hidden software flaws, it delivered massive, lethal doses of radiation to patients.
The requirements failures here were just layered, one on top of the other. The blueprint never defined what should happen if certain software errors occurred. It had these hidden timing flaws. It blindly trusted code from older machines, just importing all the old assumptions without retesting them. And maybe the worst part, the designers completely misunderstood how the operators would actually use the machine, leading to fatal data entry mistakes.
The lesson from Therac 25 is just brutal and direct. Requirements are not just about the happy path. The ideal scenario where everything works perfectly. They absolutely have to model what happens when things go wrong. Because if you neglect failure handling in a high-stakes system like this, people die. It's that simple. Now, these stories are grim, I know, but they are not inevitable. These are warnings that we've learned from. So after seeing these disasters, the big question is, how do we stop this from happening? How do we get from chaos to control? Well, the answer lies in having a structured, disciplined process for building things.
And this is it. It's called the Software Development Lifecycle, or SDLC for short. It's basically the formal map for building high-quality software. And notice what's right there, at the very beginning. Step 1, Planning and Requirements Analysis. It's there for a reason. Every single other step, the design, the development, the testing, it's all built on the foundation you lay in that first stage. Get that wrong, and the whole thing comes crashing down.
Now, there are a couple of different ways to move through these steps. The old school way was called waterfall. Think of it just like building a house. You pour the foundation, then you build the frame, then the walls. Each step has to be totally finished before you can start the next one. It's super rigid. The modern approach is agile. It's all about being flexible, working in these small repeated cycles. Agile actually welcomes change, and it focuses on delivering working software all the time, letting teams adapt as they go.
Building on that agile mindset,
modern teams have developed some incredibly powerful tools to enforce clarity and consistency, to create a real safeguard against the kind of chaos we were just talking about.
And one of the most important tools is the design system. It's way more than just a style guide. It's a living, breathing library of reusable parts and crystal clear standards. It becomes the one single source of truth that everyone, from designers to developers to managers, relies on.
So what's actually in one of these? Well, you'll find the visual basics, of course, like color palettes and fonts, but the real power is in the component libraries, pre-built, pre-tested things like buttons and forms. It defines standard ways for users to interact with the system, and most importantly, it creates a shared language. So when a designer talks about a primary button, the developer knows exactly what piece of code that is. This just eliminates ambiguity, which is the root cause of so many requirement failures.
And the core benefit is so clear. By standardizing all these building blocks, teams stop wasting time reinventing the wheel. They can do more with less, which frees up all their brain power to focus on solving the really tough, high-value problems for their customers.
Okay, let's bring this all together. I want you to stop thinking about requirements as some boring piece of documentation. It's time to reframe them for what they really are, one of the most powerful strategic tools you can possibly have.
I mean, think about it. Solid requirements are your #1 shield. They're your defense against a project just spiraling out of control. They act like a diagnostic tool, revealing major flaws before a single line of code ever gets written. They're the safeguard that would have demanded a kill switch for Knight Capital, and the process that could have exposed the fatal flaws in the Theric 25. It's how you stop a catastrophe before it even begins.
So I want to leave you with one final thought to chew on. Based on everything we've covered, what do you think is the single most dangerous type of requirement to overlook? And why is its absence, the thing that isn't there, so often more devastating than any missing feature you could have possibly built? Answering that, well, that's the essence of building systems that are resilient, safe, and truly effective.